Good morning, all of you. So, good afternoon to everybody. Welcome you guys. Welcome you all. How you are doing, everybody? कैसे हो सभी लोग? Very good afternoon to all of you. So, एक minute, 1 minute. Yes, am I audible to everybody? Is audio video is clear to everybody? Will you please confirm? Is audio video is clear to everybody? Yeah, fine. Clear now, everybody? Is the audio video is clear? Can you please confirm? चलो चलो let's continue our discussion. So last class we have completed the 85 problems completed now. Chalo, let's move to the next problem. 86. Take this problem, all of you. If P and Q are two random events, then the following is true. Then the following is, which are the following is correct. The first one, independence of P and Q implies that P of P intersection Q are 0. So they are saying that, so P and Q are independent. If the P and Q are independent, what is the P of P intersection Q? Is a P intersection Q is 0? No. So this is galat. And P of P intersection Q is greater than P of A plus P of B. Is it correct? No, this is not correct. So you can see now here, P of A plus P of B, that is greater than P of A intersection B and P of A plus P of B, which is also greater than P of A union B. Okay. Next, if P and Q are mutually exclusive events, then must be independent. Independent and exclusive, these two are alag alag hai. Independent and exclusive, these two are alag alag concept hai. Next, so here see this thing here, P of A, which is greater than or equal to P of A intersection B, isn't it? So कौन सा option, tell me? Option D, not B. Is it fine? Can you repeat that fixed variable questions? Okay. 85 question now. This problem now. Now look at now here. First of all, try to understand the problem here. 7 accidents occurred in a week. What is the probability that they all occurred on the same day? Same day. So here, for this purpose, for the understanding more clearly, what we can do here, Let us start with the sum. Instead of going for 7 accidents, let us start with the 2 accidents and 2 days. Okay, let us assume for easy understanding purpose, let us say we have a 2 accidents are happened. Two accidents and should happen in 2 days. Consider. Okay, so now let us consider here. Now, so what we can treat now here, we should assume that all the 2 accidents can happen on the same day. So you can see now here the 2 days A and B we have considered. A and B are the 2 days we have considered. Now let's see this thing here, the possibilities. Let's see this thing here. The possibilities, how many possibilities are there? You tell me sample space. Let us say here, yes, now we can consider here, this is A, 0 accidents, 2 accidents are happened in B. And this is 2 and this is 0. Okay, now what else possibilities now here? We can say this as, so this is what we can say, this is 1 and 1 happened. Now any other possibilities is there, you tell me? Any another possibility? Any other possibilities there, tell me? One accidents on one day, other accidents on the other day happened. So here, what else the other possibilities you tell me? What else? Any other possibilities are there? Yes, so this is what we can say, both can be 0, 0 also possible or not? Then what is the total sample space you tell me? Total possibilities, how many happened? You see this thing here? That is 2 square possibilities. How many? Tell me now. 2 square possibilities. Accidents doesn't, so we need to see the sample space here. So we are talking all possibilities, we are talking. Jay, we are talking about all possibilities. There may be some day, so those no accidents may happen. We have taken, so those 2 days we have taken. Means in this A and B, accidents may not happen. Now, some other day may happen. Okay. Now you tell me now how many. So what is here? They are saying that what is this thing? All the accidents might happen in the A if they are asking. So if they are asking probability that all the 2 accidents happened happened on the same day. Now you tell me now here how much is probability we can say. How many favorable events you tell me now here? 2 accidents have happened the same day. So this is one favorable event. This is a favorable event or not? What we can say, tell me now, 2 by 2 square. Understood? 2 by 2 square. Try to understand. Now let us extend this thing here a little more. Now here earlier we have taken the 2 accidents. Now let us say here we have 3 accidents. Okay, we have taken the 3 days. Okay, now let us say this is A, B, C. Now tell me the possibilities now here. A, B, C. How many possibilities can happen? So tell me. Here 0, 0, 0. Yes, tell me now here. 0, 0, 1 accident happened. Hmm? Like that. So here we can do the combinations, we can do it or not. How many combinations like that we can able to do, you tell me? How many combinations we can able to do, you tell me now, like this? Hmm? How many combinations we can able to do, you tell me? Yes, that is what we can say now here. 2 cube combinations are possible or not? 2 cube combinations are possible now, tell me? Yes. So how many combinations we can do, you tell me that. 1 means here is a 3. So favorable events are how many, tell me? Favorable events, if I say n of a, that is favorable events, what we can say now here? 3. Favorable events are what you tell me now? 3, 0, 0, 0, 3, 0, 0, 0, 3. Okay. These are the favorable events. Can you tell me now probability to occur all the 3 accidents have happened on the same day? All the 3 accidents happen on the same day. No, it doesn't work like this. No, it doesn't work like this. Okay. So it should be given as what we can say now, P of A, if I say that should be 3 by, so no, sorry, here I think here we'll get it as a 3 cube will come, I think so. Check it here. Here it will come 3 cube. Yeah, do check this thing. That only we are doing now, Jay. So that only we are doing here. Hmm. Like this. Now you tell me now here. Now did you understand the scenario? You tell me. Here we have taken the 7 accidents and 7 days. Means what, tell me now, favorable events n of s, you tell me. Sample space is what we can say now, 7 power 7. 7 power 7, and the sample favorable events is what we can say, 7. Yes or no? So then what will get the probability, tell me now here? 7 by 7 power 7. Yes, that is 1 by 7 power 6. Got it? Next. Take the next problem. Find the probability of not getting a total of 7 or 11 on either of two tosses of a pair of fade die. So here, so we are not get this thing is 7 or 11. Find the probability of not getting a total of 7 or 11 on either of two tosses of a pair of, means two dice. I should not get a sum 7 or 9, 11 I should not get. So tell me now here, we know 12, 11, 10, 9, 8, 7. For this, how many possibilities we know? This is one possibility, this is two possibility, and this is three possibility, this is four possibilities, and this is five, and this is six possibilities. Isn't it? Tell me. Now they are saying that not getting, I should not get. That means I should not get 7, I should not get and 11 also I should not get, isn't it? 7 I should not get, 11 also I should not get. Hmm? So tell me now what we can do here. So how we can write now? 7 I should not get. 7. So here tell me now here. So that is probability of 7 I should not get. This should be given as what we can write to tell me now here. 7 possibilities are what you tell me. 7 also I should not get. 11 also I should not get. So what is the probability to get a 7 or 11? We can do like this, fine. So this is nothing but what we can say here. P of 7 intersection, or we can write this is union 11 whole bar. चलेगा? 1 minus P of 7 union 11, which is given as 1 minus 7 possibilities are what we can say, tell me 6. So 6 by 36 plus 11 possibilities are 2 by 36. So this will be given as what we can say 1 minus 8 by 36. How much this value, tell me? What's the answer? How much the answer? C. 7 by 9 na? Repeated. Next one. Find the probability of where 4 turning up at least once in 2 tosses, at least once in 2 times 2 tosses. Okay, so tell me now here, at least once we have to get it. Okay, 4 times 4 has to come at least. Pongal I think so. 14 I think so. 14 I think. Isn't it? Pongal is on 14 na? Tell me now 4 has to come. Yes, now here, what is the probability of getting a 4 you tell me? That is 1 by 6. And not getting a 4 is what we can say here? 5 by 6. So how many times we have tossing you tell me? 2. So means what we can say? At least 1. Yes, what we can say here? 2C1. And what we can say? P power 1 by 6 binomial power 1 and 5 by 6 power 1 plus 2C2 and 1 by 6 power 2. How much will get? How about this answer? 5 11 by 36, right? Chalo, next problem. Next. A candidates were asked to come to an interview with 3 pens each. Black, blue, green, and red were the permitted pen colors that the candidate could bring. The probability that a candidate comes with all 3 pens having the same color. Okay, so will you try this problem? It's a 16 problem, good problem. So we have a 3 pens asked to bring. The candidate has a colors of black. It has a so different colors. So this okay, try color. So this is black, green, and red. These are the 3 colors. Fine. This is one बहुत बढ़िया problem. Listen here, I'll ask you carefully. So first of all, so now here, can you write the sample space first of all? We'll write the sample space first of all. So 4 pens, the 4 colors, among these 4 colors, the student can bring any 3 pens has to bring. What is sample space, you tell me now? The student can bring all black. Okay, 3 pens only has to bring all blacks. Yeah, all blue. All green. Are all red. Yes sir, no, this is a possibilities. Exactly. Now here the student among this thing, so how many ways we can able to arrange, you tell me? How many ways the student can bring, you tell me now here? The sample space, these are what you tell me now here? These are the favorable events. N of A is what you tell me now here? 4. Favorable. And can you tell me now N of a sample space? That is a 4 factorial hoga 4C3. Yes, 4C3. So among this thing the student can bring any 3 he can bring now. All of you. So you can see this thing, how much is value of 4C3 equal to 4C1? इज इट? चेक करके बोल, ये सही होगा क्या? दिस इज द सैंपल स्पेस, isn't it? This is thing. Now you tell me now here, the student can bring, you tell me now here. So this is the sample space we got. Now let's see the all the remaining things also. The student can bring black, blue, green. The student can bring black, blue, red. See the combinations. And the student can bring blue, green, yes, blue, green, red. And what else you tell me now here? Black, green, red. Now this is a possibilities. Next. Now here one has bring. Now the student may bring the two also may bring the same colors. He may bring the two. So means the student can bring two black, one green. Yes, two black, one blue. Two black, one red. This is a possibilities. So you can look at now here. The student can bring two blue, one black, two blue, one green, two blue, one red. Student can bring, right, so two green, one black, two green, one blue, two green, one red. So two red, one black, two red, one blue, two red, one green. कोई possibility होगा क्या other than this? So if you understand, you tell me this thing here. Agar these are the possibilities, you tell me. No, for all we wrote, yeah. What we wrote, this is for all four colors we wrote, na, not for one color. All the four colors are there, you can see. Now here we have four, yes, four, 6, and this is 6. Total is how much, you tell me now here? Probability. And these are the desired na Favorable events are, these are favorable events, that is 4. Total is how much, you tell me now? 20. So you tell me now here how much we'll get? 1 by 5. No, yeah, sample space is 20, not 64. How we got 64, you tell me? N of S is 20. Okay. Is it clear? Hmm. Chalo. Next problem. And so while you are practicing, here, so don't leave these papers. So here these papers are GATE 2014, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. These papers try to solve perfectly. Okay, these papers you try to solve perfectly. Then, yes, now take the next problem. An urn contains 5 red, 7 green balls. A ball drawn at random and its color is noted. The ball is placed back into the urn along with another ball of the same color. The probability of getting a red ball in the next draw. Now tell me now here. A box contains how many balls? 5 red balls, 7 green. A ball is drawn at random and its color is noted. The ball is placed back into the urn with another ball of same color. Means an extra ball we have placed now here. Tell me now here first. Let us consider first I have taken the red ball we have taken. Now tell me now what is the probability of getting a red ball for the first time? That is 5 by 12. We got the red ball. So once if I got the red ball, what they're doing here? That red ball is placed back and one more extra ball with placed along with another ball of same color. Now the red balls are how many? 6 red balls. Now second time also I should get which ball is a red ball only I should get. How many red balls are there, you tell me? How many red balls are there now? 6 red balls. From 6 red balls, we need to select. So here how many balls are total balls? One increase or not? 13. This is one possibilities. And let us say first time you got the green ball, we got it. What is the probability of getting a green ball? Green ball probability is what will be 7 by 12. If I got a green ball, that green ball, again one more green ball we have placed back. Now how many green balls are now? 8. 8 total balls are how many? 13. Okay. Why here 12? Second time I should take the only green ball only we should take na. So what's the option? What happened here? Doubt in this thing? Look at. Second. Oh, second time I should get red na. Okay, sorry. Then 5 by 13. Sorry. 5 by 13. Yes, 5. We should second time I should get a red only na. Second time I should get red only. Yes, correct. They are mentioned na. So they are saying that, so here how many draws happen? A ball is drawn at random and its color is noted. Okay, the color is noted. Again that ball has been replaced na. Right. Isn't it? Tell me. The probability of getting a red ball in the next draw means pehle ball we should do it na. After, so here this thing first draw plus second draw दोनों कंसिडर करना पड़ेगा. Second time, how many red balls are there? Hmm? How many? So here, first time. Okay, so here we have a 5 red balls. We have 5 red balls and 7 green balls. So we should take second time. We should take which ball? We should take now red ball only. We should take. Second time, how many red balls are? Green is increased now. We added 1, but red balls are remain same 5 only. Red balls are 5 only na. Done. What's the answer? 65 by 156. Next one. The probability of getting a head in a single toss of a biased coin is 0.3. The coin is tossed repeatedly till a head is obtained. If the tosses are independent, then probability of getting a head for the first time in the fifth toss. First time in the fifth toss we have to get. Tell me. Yes, means here it should be tail, and this is head we should get now. Fifth task must be this thing. Can I do any shuffling is possible here? Can I do the shufflings? No. They given here this is what coin? Biased coin. They given probability of getting a head is how much this value? 0.3. So tail probability how much? This is 0.7. So this is 0.7 power 4 into this is 0.3 na power 1. This is unbiased coin, no shuffling. So how much this value, tell me? Next, the probability that a screw manufactured by a company is defective is 0.1. The company sells screws in packets containing and gives 5 screws guarantee of a replacement. If one or more screw in the packet is found to be defective, the probability that the packet would have to be replaced means, see this thing what they are asking, the probability that a screw manufactured company is defective. So manufacturing of defective probability they given us what to tell me, probability to defective is 0.1 and the not defective probability is what we can say 0.9. The company sells screws in packets containing and gives 5 screws of a guarantee of a replacement. Packets containing 5 screws. Okay, here comma. Okay. Uh, so here guarantee of replacement if one or more screws is if found to be defective means what tell me, if at least one is defective, they'll replace the packet. If at least one is defective, they are replacing n value. How many packets they are saying in packet? Each packet contain 5. They are saying if at least one is defective, they replace the packet. Yes or no? Means, so probability of they are saying this as at least one. What is the at least one probability is? Tell me. 1 minus none. What is the at least one probability is? What, tell me? 1 minus none. So you can tell me now 1 minus none probability. Yes, 1 minus none means what we can say here, 1 minus none means no, this is no screw is defective. No screw defective means what we can say, tell me, 5C naught into this is 0.1 power 0 and 0.9 power 5 होना पड़ेगा. So then we'll get it as 1 minus, how much you tell me, 0.9 power 5. Tell me how much is value. This is 0.095. At least 1 minus none. Next. Three cards are drawn from a pack of 52 cards. The probability that they are kings. King, queen, jack. Yes, first one we should get it as a king, queen and jack. This thing. We can, shuffling can be allowed now. 3 ways we can do it. 3 factorial ways we can shuffle them. Right. Now you can tell me now here, king probability ka tell me how much? 4 by 52. Next, After that 4 by 51. Next 4 by 50. How many ways we can shuffle them? So 3 factorial ways we can shuffle them. How much will get, tell me? Into 4 into 4 into, yes, by 52, 51, 50. 3 factorial means what, tell me? 3 into 2. What's the answer? Yes, that is 16 by 5525. Option A. So here YouTube hours are sufficient if we say. So here remember, if we can able to plan properly, you can easily YouTube hours are sufficient. So here Amina, so what I used to say here, so and you complete one subject from in the YouTube and start doing the PYQs of a that particular subject. What are the subject you did? Yeah, you did. Now you will get to know yourself. If you can able to solve the minimum of the PYQs and purchase the PYQ previous year's gate questions and try to solve those questions. If you can able to solve the by after attending the complete course, if you can, let us say you have taken any one subject you have taken, if you can able to solve this as a 80% of the problems, 80% of the problem, then so here your preparation is SII, you are learning the best you are learning. If you can able to do these many 80% of the problems you can able to solve it. Okay, so here and you can, so you are the first semester only, you have enough time is there, so you try to learn one subject, any one subject from YouTube, and thereafter you can start. Yes, and if we have one, so here teacher का help है तो आपको, so you will be in a proper track, you will be, so here her doubt will be cleared easily. Okay, so then you have sufficient time, so here no need to be join any coaching or immediately now only. So learn any one subject from the YouTube and start practicing the previous year gate questions. Then you will get to know how much you are understanding, whether you can able to solve this thing or not. So then after you can decide. Now see the next problem. A fair coin is tossed n times. The probability that head does not turn up in any of the tosses. Head should not come. Head should not come. Head should not come means all tails होना पड़ेगा ना. Means what the probability for all tails you can tell me now here. So probability of getting a head is 1 by 2 and probability of not getting a head is also 1 by 2. Fair coin na? So that's why equal probability. Now you tell me now here for not getting the head. So that means what we can say here, n c naught 1 by 2 whole power 0, 1 by 2 whole power n, nc naught is equal to 1 na. So we'll get this as 1 by 2 whole power n. Next, x and y are two random events. It is known that P of x is equal to 0.4 and P of x union y bar is 0.7, which are the value of P of x union y. P of x union y bar, which means what we can say, P of x plus P of y minus P of x intersection y bar. And this value given us, what, tell me, 0.7. The last problem, 1 minus all, yeah, that also 1 minus all, what we can do, yeah, here what they are asking, here the probability head does not come, na, head does not come, how we can do, head should not occur, uh, all head, uh, so how we can do, tell me, they given this as a 0.7. So this is P of x plus P of y bar. P of y bar, and these are independent events. Now we can say P of x into P of y bar. Right. So this is 0.7, which is equal to, and we can write this thing as what, tell me now, point P of x is 0.4. If I take the P of y bar common, 1 minus P of x. So from this, what will get out? This is 0.3 na, and P of y bar into this value 0.6. So here, tell me now, here P of y bar, how much will get? This is 0.5. Then P of y bar, so then P of y, which is equal to 0.5. We need what, tell me now here, अभी हमको क्या चाहिए, P of x union y, which is given as what, tell me, P of x plus P of y minus P of x intersection y. For no head, we can do 1 minus all head. Okay, same thing now, yeah, we can do. So which could be P of x is what, you tell me? P of x is how much? 0.4 na? Plus P of y is how much? 0.5. Intersection P of, yes, since these both are independent, so P of x into P of y we can write now. X and y are independent events. So this is what we can say here, 0.9 minus 0.4 into 0.5. Tell me how much we'll get. This is 0.7. Check it, all of you. Which distribution you mean to say here? Look at now here. So now here is the sum of the probabilities which is equal to 1, probability of occurrence and probability of not occurrence. Yes, if the probability occurrence plus probability of not occurrence, if it is 1, then we can go for binomial. Okay, the sum of the probabilities, probability of occurrence and probability of not occurrence, if it is equal to 1, then we go for binomial. Okay, so the same thing we did now here previously, and so here probability of getting head and not getting a head. Sum is 1 now, p plus q is equal to 1, that's why we can go for binomial. Is it fine? Next one. And take the next one here. What are they given? Suppose that a shop has an equal number of LED bulbs. We can you can try, you can do. So 1 minus none is possible, 1 minus all hex also, yes, that is also one possibility. We can do that also, that way also we can do it. Now tell me this problem, let's finish this problem. What are they given here in this case, you tell me. The shop an equal number of LEDs of two different types. The probability of an LED bulb lasting more than 100 hours given that is of type 1 is 0.7 and given that is of type 2 is given as 0.4. So that means what now here we have two types of bulbs we have. One is the type 1, which is what tell me probability is 1 by 2, and the type 2 which is also 1 by 2. Isn't it equal number of bulbs we have? Isn't it? What they has mentioned now here, the probability that the LED bulb lasts more than 100 hours if it is of type 1, which is given as what tell me 0.7. and the probability that if it is of 100 hours and more, last for this is what tell me type 2, which is given as what tell me 0.4. Now probability that LED bulb chosen at random last more than 100 hours. This is the total probability na, more than 100 hours probability, which is given at type 1, that is 1 by 2 into what I can say 0.7, and type 2 1 by 2 into what we can say here 0.4. Tell me how much this value? 0.55. Right, this thing. Right. Yeah, we can make tree diagram, we can do it. Yes, tree diagram also chalega. Okay, so here don't neglect this as a, so 14, 15, 16, these problems are very good problems. Try to solve these questions. Okay, fine. Yeah, so we'll continue in the next class, we'll continue. Okay, so we'll meet in the next class. Okay then, see you. Bye bye.